All right, welcome back. Today we're going to be looking at how to calculate the mean, median, and mode of a set of data. And these three statistics are really important in determining where the center of a set of data might lie. So descriptive statistics give us information that summarizes key features of the data. As we saw from an earlier video, when we're describing data, we try to give an indication as to what the central tendency is, as well as dispersion, how far the data spreads out. And so some examples of statistics, sometimes they're also called summary statistics, are the mean, the median, the mode, the range, and there are a bunch more. And in this video, we're just going to be looking at statistics that tell us about the central tendency of the data. So ones like range and standard deviation will go into a future video, but we're going to be looking at those three M's today. So the mean is another word for the average, and you might have learned how to calculate this from a previous class, but if not, it's relatively simple. So to calculate the mean, we'll have a set of data values usually listed in a table, and we'll take each value and add them all up. So we'll add up all numbers in our data, and then we'll take that total and we'll divide it by essentially the number of numbers. How many data values do we have? And so in a more formal definition, you might see a mathematical formula for this, and it's represented by sum from 1 to n of xi divided by n. And so this is just another fancy way of saying the same thing. The sigma, capital sigma here means summation, and so we'll add up all of the data values, and the xi over here represents some arbitrary data value. So you know how in algebra you use x to denote a variable. Here x represents some data point, and eventually we'll add up all those xi's, all of those different data points, and divide by n, which is the total number of data points. Next, we have the median. The median is the quote-unquote middle number in a set of data. So it's the one such that half of our data values are bigger than that number and half of our values are smaller than that number. And to find the median, we usually, probably the easiest way to do it is to list out all of the data values in ascending order, meaning from smallest to largest, and crossing out the smallest and largest value on each side until we get to the middle. So what do I mean by that? So if we take some set of data here, I'll just make one up really quick. This will be a case where we have an odd number of values. Here you see we have 7 data values ranging from 1 to 25, and I've listed them out in ascending order from smallest to largest. Finds the median, we can, on each side, we will cross out the smallest value and the largest value to keep it balanced. And then we'll cross out the next smallest and the next largest, and the next smallest and the next largest, until we have just one number left. And here in this case, we can see that the median is 10. But it won't always be quite that simple. For example, if we have an even number of elements, so I'll do another example here where instead of having 7 data values, we will have 8 data values. And we'll do the same thing here. We'll cross out the smallest and the largest, the smallest and the largest, and the smallest and the largest. And now we're down to 2 values, a 14 and a 16. If we did this again where we cross out the smallest and largest, we'd end up with no numbers left over. So what will we do? Well, when we have an even number of elements and we get down to the 2 in the middle, the median is the number exactly in between those two. It's essentially the average of those two values. So we have a 14 and a 16. So to find the median, we would add those two numbers up and divide by 2 because we're only dealing with two numbers here, which gives us 30 over 2, which is 15. And that will be our median in this case. And for any data set where we have an even number of values and we end up with 2 in the middle, we'll want to copy this method to get the median. The mode is probably the most straightforward of these three statistics. The mode just asks us which number pops up the most. So in a graph where we went over histograms in the last video, say we had a graph that looked something like this. Not drawn very well to scale, but should still work well. Here we have 0 to 2. Each bar represents an interval of width 2. And the mode would be the interval or the bar that has the highest frequency, has the most values in that interval. So in this case, we see that this bar would be representing values from 2 to 4, and it's the highest bar in our data set, which represents the highest frequency. And so this would be our mode. In any histogram or bar graph, the mode is going to be the one, essentially the bar that is the tallest. Or if there are multiple bars that have the exact same height, then each of those would represent a mode. And when we are dealing with data values listed in a table, it will be the number or the observation that shows up the most. So if we have, for example, a data set 1, 2, 2, 2, 6, and that is our data, the mode would be the number that pops up the most, in this case 2, because it shows up 3 times, which is more than any other value. And so now we're going to look at a couple of examples, a couple of example problems to kind of reinforce this. These are both taken from a textbook I've used in a previous statistics class. The first one here is about shaft graves in ancient Greece. So it tells us to refer to a study of sword shaft graves in ancient Greece. The number of sword shafts buried at each of 13 discovered grave sites is shown in the following table, and it gives us our data. And then it's going to ask us a couple of questions, kind of reinforce the statistics that we've gone over in this video. So part A, calculate the mean of the data and interpret the result. So starting with part A, we want to find the mean, which is about adding up all of the values in our set of data and dividing by the number of numbers. So in this case, we would do 1 plus 2 plus 3 and so on up to 9. And then we'll take all those numbers and divide by how many data values we have. And thankfully, it tells us right away in the problem that there are 13 values. And so when we add up all of those, we end up getting 42. And this is the number that we divide by 13 to get about 3.23. And when it asks us to interpret the result, that means to take this number and put it back in the context of the problem. So we would say that the average grave site in ancient Greece will have about 3.23 sword shafts on average. For part B, we want to calculate the median of the data. And so when we do this, we want to take our numbers and order them from smallest to largest. So we see we have 3 1s in this data. And then we have 4 2s. And then we have a 3. We have 2 4s, a 5, a 6, and a 9. And so this ends up being an odd number of data values, which makes it a little bit easier for us, but we'll start crossing out the largest and smallest values on each side. And you can see when we do that, we are left with one number in the middle, which is 2. So our median is 2. And to interpret this result, we would say the median number of sword shafts in these grave sites in ancient Greece is 2 sword shafts. Half of grave sites will have 2 or less sword shafts in them, and half of these graves will have 2 or more sword shafts. And then in part C, we want to find the mode of the data and interpret the results. So the mode is the number that shows up the most, and we can see from when we wrote all of these out when finding the median that 2 is actually what shows up the most. It shows up 4 times, and so that is our mode. In interpreting this result, we'd say 2 sword shafts is the most common number of sword shafts that we observe in these burial sites. And now looking at one more problem, which goes a little bit deeper. This one is about the cheek teeth of extinct primates, and it gives us some data on the depth of molars in various extinct primate species, and it gives us this data on 18 different teeth extracted from these primate skulls, and gives us the depth of them in millimeters. And now going back to these questions, which are about finding the various summary statistics for this data. Part A, find and interpret the mean of the data set. So once again, we will take all of the data values, starting with 18.12, and then adding 19.48, and so on until we've added up all 18. It looks like the last one is 16.2. And divide by the number of data values we have, which in this case is 18. And so when we add all those up, we end up with 296.99 divided by 18, which gives us about 16.5. And so in this case, we would say the average depth of a molar in these extinct species cheeks is 16.5 millimeters. And now it asks us, if the largest depth measurement in the sample were doubled, how would the mean change? Would it increase or decrease? Well, if we think about this, the largest tooth in this data set looks to be 19.7 millimeters. So one of these values that we added up is 19.7. Now, if we doubled this and we made it instead a 39.4, and we calculated the mean again, we would find that the mean would increase. And while we don't know the exact value that the new mean would be, we could say automatically it will increase because this numerator will be bigger. If we double one of the values that we added up in the numerator, then the new numerator that we get must be bigger than this original one of 296.99. And so when we divide by 18, we will get a value that is larger than 16.5. So the mean will increase in this case. For part B, find and interpret the median of the data set. So once again, we would order them from smallest to largest. So it looks like the smallest value in this data set is 13.25. And we would order them from smallest to largest. So the largest going up to 19.7. And then begin crossing things out, smallest, largest, and so on. And we would find that We have two values in the middle because there is an even number of data values, data points in this set. And the two middle values are 16.12 and 16.2. And so to get the median, we would add these two up and divide by 2 to get the middle value of these two. So when we add them up, we would get 32.32 divided by 2, and that gives us 16.16. And this is our median. Now, if the largest measurement in the sample were doubled, would this also increase the median? And the answer to this is no, because no matter how big this 19.7 is, and this would be the number that would be doubled, even if we double it to make it 39.4, it will still be the first largest value that we cross off. And it will actually have really no effect on the median. But we'll still be crossing out the same value, smallest, largest, and end up with the same 2 in the middle. And our median will still be 16.16. And now lastly, note that there is no single measurement that occurs more than once. And so how does this fact impact the mode? So there's two ways you could look at this. You could say that there is no mode because each value only occurs once. There's no value that shows up 2 or more times. So you could say that there's no mode, which is probably the most common way to look at this. But you could also say that the mode is all of these values because they all occur the most amount of times, exactly once. So you could either say there's no mode or there's 18 modes, where each data value is a mode. In general, I would tend to say that there is no mode in this situation, where each one only shows up once, because I think by saying that there's 18 modes, you could get the wrong idea, and think that there's several values that represent the central tendency, when in reality that is not what this would tell you. If you said there are 18 modes, in this case, because each one only shows up once, it doesn't really tell you anything about what the center is, because each value is representing a mode. That's all I have for this video. In the next one, we will go over some statistics that will help us learn more about how to summarize the spread in a data set, so range and standard deviation in particular. And that's all I have for this.